Hi, I'm Annaka Clement, and today I'll be talking about an environmental baseline to the end-Triassic carbonate crisis, looking at the late Triassic facies of the Gabbs Formation. Before I get started, I would like to thank the North Dakota State University Geosciences Department, as well as funding sources including the National Science Foundation, Geological Society of America, and the Association of Applied Paleontological Sciences. I also want to thank my field assistants, Sarah, Caitlin, and Haley, for all their help on this project. The latest Triassic contains one of the major five mass extinctions, and has therefore been a subject of significant global research, leading to the recognition of a negative carbon isotope excursion, a carbonate crisis and potential acidification event, and the likely causative role of Central Atlantic magmatic province volcanism in these events. The Gabbs Formation is no exception, as many studies have focused on the extinction interval and recovery facies expressed at this locality. However, few studies have addressed the environments and Facies Associations of the Gabbs Formation prior to the extinction and boundary intervals. Understanding the baseline condition of the late Triassic carbonate system in Nevada provides important context for the boundary facies and serves as a comparison for early Jurassic facies. This is especially important in Nevada as the New York Canyon area exposure has been proposed as an alternative global stratotype section for the Triassic-Jurassic boundary. The paleogeographic location of the Gabbs Formation in the late Triassic is in the eastern Panthalassa Ocean. The Gabbs Formation accumulated on the continental side of a back-arc basin. Most of the basin setting context comes from the underlying and much more widespread Looning Formation. The Gabbs Formation itself is not particularly widespread, but it can be found in the Gabbs Valley Range, Garfield Hills, and Pilot Mountains of west central Nevada. However, the full extent of the Gabbs, with few intrusions, is best seen in the vicinity of New York Canyon, outlined by the red box. The study area around New York Canyon contains a series of thrust faults that repeatedly expose the Gabbs Formation and represent locations with a much wider original extent. 8 stratigraphic columns were measured that covered the full extent of the Gabbs Formation in order to characterize the facies relationships. Those stratigraphic columns can be seen here again in cross-section. The Gabbs Formation is traditionally divided into 3 members: the lower Nunn-Mine member, the middle Mount Hyatt member, and the upper Muller Canyon member. These divisions are based on lithology, and generally do match the facies divisions seen in the Gabbs. The lowest part of the Gabbs Formation is dominated by intrabedded mudstone and calcareous shale, the middle by skeletal wackestone and packstone and silty mudstone, and the top by terrigenous siliciclastic rich siltstone. We will focus on the carbonate environments and step through each in more detail. From the measured sections, the following facies associations were developed, which represent deposition on a carbonate ramp. These facies can be interpreted as deposition from the outer ramp transition to the inner ramp transition. As we step through these environments, the profile version of the facies association will help orient us. The outer to mid-ramp transition is represented by thin to thickly intrabedded mudstone and calcareous shale beds. The carbonate beds are composed of micrite and contain few to no recognizable carbonate grains in thin section. Pelagic fossils of large and small ammonoids are common on the tops of some mudstone beds, and benthic fossils are extremely rare, indicating deposition in an open water setting. The top pictured Rhabdoceras is one of the most common and easily identifiable ammonites. In outcrop, the mudstones and calcareous shales weather a distinct purple color. The lower approximately 60 meters of the Gabbs Formation is dominated by these facies. The mid-ramp deposits are represented by skeletal wackestone and packstone beds. In thin section, these rocks contain abundant carbonate grains dominated by skeletal fragments and whole fossils. Rare paleoids and coated grains can also be found in these facies. Fragments of echinoderm stereome are particularly abundant in some samples, likely owing to a sorting effect from their light porous structure. Benthic fossils are common in these facies, and ammonoids can still be occasionally found. Bivalve taxa are the most abundant macrofossil, but brachiopods and gastropods are also present. Trace fossil burrows can also be observed. Mid-ramp facies dominate the 30 meters of the Gabbs Formation above the intrabedded mudstone and calcareous shale beds. The mid to inner ramp transition is represented by carbonate mudstones with a distinct increase in terrigenous silt-sized grains. In thin section, these mudstones are composed largely of micrite, but contain rare benthic skeletal grains and common to abundant silt-sized terrigenous grains. The terrigenous silt grains are predominantly quartz and are angular to subangular. The relative immaturity indicates this environment is likely proximal to their landward source. In thin section and outcrop, silty mudstones often contain ripple, scale, trough, and tabular cross laminae near the tops of beds. Macrofossil content is much lower in the silty mudstone facies, and fossiliferous beds contain primarily small burrowing clams. Burrowed horizons are common on the tops of beds. Silty mudstones are frequently interbedded with pink-brown terrigenous siltstones near the tops of sections, and the amount of siliciclastic terrigenous material also increases up section, indicating the proximity of the landward terrigenous source. Based on the progression of these facies through the Gabbs Formation, the preserved environments are shallowing upward. Given this pattern and the evidence of an adjacent landward siliciclastic source environment beginning in the silty mudstones, we would predict to find additional siliciclastic-dominated facies up section as shallowing continues. This prediction is supported by the siliciclastic-dominated facies at the Triassic-Jurassic boundary interval, and indicates that the initial reduction in carbonate occurring well below the boundary interval is a predictable facies change reflecting proximity to the shoreline. This does not conflict with interpretations of acidification in the extinction interval or the negative carbon isotope excursion near the boundary, as the initial reduction in carbonate and increase in terrigenous grains occurs well below either interval. Given this baseline increase in terrigenous sedimentation, the evidence for acidification near the Triassic-Jurassic boundary should focus on the reduction of any remaining carbonate content in the siltstones and not on the initial loss of the silty mudstone facies. Overall, the Gabbs Formation's carbonate members, the Nunn Mine and the Mount Hyatt members, represent the progradation of shallow marine carbonate ramp facies. The most landward of which, the silty mudstones, provide evidence of an adjacent landward source of terrigenous sediment. The Gabbs Formation carbonate ramp also serves as a baseline comparison for early Jurassic environments. If there were no significant changes to the system, we might expect to revisit the same Facies Associations seen in the Gabbs as we move into the early Jurassic. Rather, we see an entirely different set of environments. Concretionary carbonates unseen in the Gabbs Formation are found almost immediately after the TJ boundary. Upsection, mid-ramp environments are dominated by glass sponges forming bedded chert deposits. The presence of early ramp microbialites are another significant difference. Iron clay ooids are found as a condensation feature in the early Jurassic, indicating a different geochemical environment than what produced the late Triassic Gabbs Formation carbonate ramp. In summary, the study of the Gabbs Formation provides several takeaways. First, the carbonate facies of the Gabbs Formation belong to a classic carbonate ramp system that is shallowing upwards. Bioclastic grains help delineate the mid-ramp facies. Second, the increase in terrigenous siliciclastic material upsection within the carbonate facies indicates the presence of an adjacent siliciclastic environment and is likely connected to the initial carbonate decrease seen well below the Triassic-Jurassic boundary interval. Finally, the baseline normal carbonate deposition in the Gabbs Formation provides a distinct comparison for the unusual recovery facies of the early Jurassic. Thank you for attending my talk, and I look forward to any questions.